Same thing with strains. You could have 3 different kinds. Ready for them? The first one is called longitudinal. The second one is called volume. And the third one is called shearing. Strain. Volume strain and longitudinal strain. Are you guys ready to yell at me? Sure. Do you know what the symbol for this is?
It's like P or V.
It's P again.
Unfortunately, it is.
Please just use a different alphabet.
Unfortunately, I can't because I need you guys to be aware of what it is, but other people on the planet use them.
We all go into like physics.
There are so many different alphabets.
I knew people were gonna yell at me. What did I tell you?
Not yelling at you, yelling at the society in which physics exists.
And this is called the Young's modulus, and this is called the bulk modulus. Sometimes also written as E, and sometimes also written as K. I tend to think YB eta. Okay, but if you ever see it, you go onto your engineering schools, you will see E or K sometimes written for them. The reason why I think of these as Y and B's, because Y is called Young's modulus, and B is called bulk modulus. And eta is called rigidity modulus. And what is a modulus? It's called modulus of elasticity. And that is defined as stress over strain. And it is always a number. So it'll always be a number. But no matter what material you have, it will give you a number for it. So what is Young's modulus? Y is defined as force per unit area divided by delta L over L0. B, bulk modulus, is defined as minus delta P over delta V over V0. And eta is defined as F over A divided by tangent of theta.
Why is it changing pressure with all modulus?
Good question. So what happens to the volume if you increase pressure?
Changes.
How?
Negative.
Did everybody get that? Does everybody understand why there's a minus? What happens when you decrease the volume, increase the pressure? That's why the negative sign is there. Okay. So why is there a tangent of theta in here? So let me explain that. So if this is your volume, shearing strain does what? Pulls it, right? Or either way. So imagine if it pulls it, it goes like this. I know it's a bad picture.
It works.
So close enough? It pulls it here. If this is delta X, so this will still be delta X. If this angle is theta, can I rewrite this as eta equals F over A divided by delta L over L0. That's from my Young's modulus definition. Is this the change in L? Is this delta L? Yeah? So can I write this as F over A divided by delta L over delta X? What is delta L over delta X in terms of theta? There we go. So this is actually F over A divided by tangent of theta. That's where this comes from. Got it? Longitudinal strain is strain in 1D. Bulk modulus is strain in 3D. Whereas eta is the shearing strain, right? Goes opposite to each other. Good? Okay, so now can I also define another thing for you? Young's modulus measures the springiness of a material in 1D, right? How much will my spring come back to its original state? Bulk modulus measures the compressibility of a material. And this is in 3D. When B is small, the object is compressible. For example, a gas. When B is large, the object is uncompressible. Is that a word?
Yeah.
For example, a solid. It can't be compressed, right? I mean, I'll need a lot of force to compress it. It'll just stay there. But with a gas, you can easily compress it. Why is there a negative sign?
Because pressure and volume are inversely related.
Perfect. Because pressure and volume are inversely related. You guys should write that somewhere. Because pressure and volume are inversely related. Okay. Ooh, this looks actually quite nice. I like the way this looks. Looks very pretty.
Using back on that.
Okay, so one thing other that I would like to tell you about the difference between y and eta. So did you see that I started with the same definition when I was defining eta? But then why did I put it in a different box? The reason why I put it in a different box is because they measure different things. Talking about that, I'm going to now, so the difference between y and eta. So what was y? What was y? Right, no, but what did we call it? Young's modulus? And what was eta? Good. So what's the difference between them? So eta measures the stiffness of a material, whereas y measures the springiness of the material. So it just means one is measuring how stiff something is before it breaks, and the other one is measuring how elastic something is before it deforms. Right, so elasticity is both. It's just measuring different qualities of them. And that is one of the things that confuses everybody. So just wanted to make sure that you knew that, right?